Okay, hello everyone. Welcome to my kickoff of my new projects called Amethyst. Mm, Today I will explain what is the project and what are its goals and uh, what I would like to achieve by this project. After a few months of learning Objective-C language and AppKit um, framework for macOS operating system. Mm, I finally reached the phase where I am uh, ready to mm, use my newly acquired skills in the uh, real life project. So, what is Project Amethyst and what is the primary goal of the project? So I'm coming from the mm, R programming language world. I used R language for data analysis and creating visualization and dashboards with R. So I also contributed to R language and fix a few bugs. Especially, I was focused on macOS platform and Quartz device. So I decided that I would like to uh, create new graphics device for our language, which would run on macOS operating system. Uh, of course, on macOS, there is already a graphics device. Uh, Not only one, a few of them, but the default one is called Quartz, mm, and this was the device I was uh, contributing to. So I was interested how it works, and I decided to create also a new one. So what was my motivations? Why create a new device if one already exists? So my motivations, first of all, were to deepen my knowledge about how our language, especially in context of graphics, uh, really works underneath. Thanks to that I expect me to deepen my level of contribution to our language, and also because I'm interested in R and macOS platform and graphics in general. Uh, this these three interests uh, join together uh, in this area. The second motivation is that fixing some bugs. I've seen that uh, uh, a few things didn't work flawlessly as I expected on graphics side. Uh, so, mm, boldly speaking, I wanted uh, to fix this, but I uh, predict that uh, the biggest part of fixing it would be also learning what my predecessors already achieved through the years. So I can say that we all stand on the shoulders of giants, and thanks to that we can look farther. And I expect also gain a lot of knowledge how to implement such graphic devices. And third motivation uh, was really finding some potential innovations, but mm, I really believe that true innovation is done by doing and exploring things, not only by um, sheer theoretical uh, exploring ideas in my mind. Uh, it's important to do something, show to other people, and test it by myself, by other people to see how can we compare it to other things which are already in the world. Mm, I really need to uh, feel the implementation details which are connected with such a project to potentially find some new ways of doing the things we are already doing for years. A little mm, explanation uh, of the project's name. So on the left, on the left side, we see the quartz mineral, which is quite common in the earth, but this is also, of course, the name of the Apple's framework for 2D rendering, and the same name was used to name the Ars graphics device on macOS platform, Quartz, as well. So uh, this is what existed for many years in Ars world, but I chose the name Amethyst because this is basically also quartz, but with some additional mm, behavior of ferrum atoms, which under the influence of some radiation, they emit such a beautiful violet color. So I can say that I hope that Amethyst as a project will be extension uh, rather uh, which bases in many areas on quartz. So it's rather something not revolutionary, but mm, evolutional. So my first motivation was to deepen my knowledge of R's graphics capabilities. So how does it all work currently? Uh, so R has uh, quite interesting and wise graphical architecture, which enables it to have some to some degree standardization of how graphics, especially data visualization and charts, to look the same on different platforms, especially three major platforms, which are macOS, Windows, and Linux. So this is made generally by unifying some some API, which is this black box I called R graphical API in the around graphic devices component. Mm, uh, this API enables everyone who develops some uh, charting graphical packages, R packages, which are some examples are put on the left, to use the same common, I can say, low to mid level API with uh, like basic atomic graphical commands. Um, and this API is like uh, inside the R language, so it's compiled the same on every platform. So on the left hand side, we have like two main graphical components, graphics, which is included in base R and currently grid the same, more complicated graphical components, which give some uh, higher level um, possibilities um, to compose more sophisticated uh, graphical packages like ggplot lattice, which uh, which greatly improves and eases chart and visualization generation by the data analyst and scientist. Plot, on the other hand, is an example of basic but also strong um, graphical function which enables users of R out of the box to a generation of charts. And plot uses graphics components, and ggplot and lattice use grid components. All of them using the same API. And on the right-hand side, we have examples of free devices, graphical devices, which are uh, really connections between this common R's API and operating system and its rendering APIs and frameworks. Yeah, so three of them, like Quartz, which is a default device on macOS, X11, uh, which is uh, enabled on the macOS platform through Xquartz additional application which should be installed, but thanks to that uh, uh, it could have been easily ported from other Unix platforms to macOS without the need to make everything from scratch. So I guess X11 was first. I have to check it, uh, but it was first, and then the Quartz was done thanks to the time bought by X11. In, in the meantime, there is also RStudio integrated development environment, which has its own device, non-standard, to not shipped with with R, but also uses R's graphical API. So inside RStudio, you can, with the same commands, also render charts. So I will demonstrate how this architecture works in practice. So first of all, let's go to our terminal. On the left, we have our terminal, and uh, let me only. Okay, so we have like this uh, three different uh, plotting packages. So the one which is already in base R, we use function plot, and by default, Quartz device is run, and we can see the plot. We can also use library ggplot, which we have to install first and import. We can now use its graphical capabilities. And now in Quartz device, we have the chart rendered. There is also another library called Lattice, and we can draw a similar plot to the first one. And this demonstrates like different graphical packages use the same device through the common API, but we can also open different graphical device, which takes some time because now Mac opens Xquartz application. And now we can check that we have two different graphical devices attached to our session. So the one active is, we check, X11. So now we repeat the same plots as previously, but on X11 device. Let's go to ggplot. And as you can see, the same plots may be different sizes, but it's a matter of scaling. And Lattice also works. All because thanks to the API, as I already said a few times, the devices are really invisible. Well, so we can like make the R independent of the operating system. And also I can bring up RStudio, which has its own R session, and also you can plot by different libraries different plots. Yes. Here you can even go through the plots I created before a few times. Okay. So now back to the presentation. And uh, and let's talk about technical design of Amethyst device. So because the second motivation for the project is really to think how to um, do what already exists, but in a different way, mm, which may be some advanced in this quite sophisticated world of Ars graphical devices. So first of all, I would like to design graphics window as separate process, which is really a separate application for macOS. Um, and let me show you why I really uh, why I really imagine this that way. Mm, let's go back to the R and our devices. So as you can see, these applications are open and they are still like connected to the R session. But what I mean by connected is different in the context of X Quartz X11 device, because as you may probably know, X11 has its own protocol, and it's mainly network protocol. So X11 and R should be connected via socket. But even if I close X Quartz device, uh, it doesn't it doesn't if I close X11 device, uh, it doesn't close our session. But if I check devices list, oh, this time, okay. So because the previous time I still had X11 device still active on the list. Probably, maybe, let me check it. Probably because Quartz was active device. Let me check it. So if I, for example, set Quartz as current device and finish X11, okay, nothing happens. So this time it's better, but so I can see already that um, something is I can show you here. So it's not always the same. This time was okay, but before, when I closed the X11 device, it threw an error and was still on the list of devices. So sometimes it behaves as I expected, sometimes not. But it's not a big problem, because I can now save my work, for example, and finish our session. But when I will close Quartz device, which I what I need to do is close it in the dock. This will finish also our session because generally this is the same process and this is the same main loop, and uh, we've sent probably the same signal to the o- to the same kill signal to the same process. So um, this small inconvenience led me to the realization of different approach mm, to the architecture of the Amethyst device, and I think uh, it has some advantages and maybe disadvantages, but also mm, possibilities of research of new directions and some promises. So what I need to implement such a graphical device which is run as a separate application, separate process, is some kind of inter-process communication. And I research a few of them because mm, Mac OS is quite rich in different technologies because it comes from Unix world, from Mach operating system, um, some BSD also capabilities, and wrappers around it done through through time by Apple. So there was some technologies I needed really to read about and choose something. Mm, so not the first one um, but after checking on a few of them, I'm focusing on message port, which is a wrapper on some Mach Mach OS capabilities in Objective C, and I guess in Swift probably as well, but I'm programming Objective C. So this is a wrapper, so it's more convenient to program by Objective C programmer, but also um, I did some simple test applications which really communicated together and exchanged some basic data. So I hope it's a promising technology, and also I hope that it will be quite fast for graphical device to send some graphical commands through the shared memory, not through the socket. How uh, how the speed will be, I will see after I implement. I hope that mm, it won't be very it would be comparable to as if I just invoke a function directly uh, in the same process. I'll see and compare as much as I could. Mm. One thing which is important to mention is that message port for now, uh, as I research, mm, needs from Amethyst application to not be sandbox application because turning on sandboxing on Amethyst application immediately cuts off interprocess communication, which is understandable, but I didn't find mm, any technology which enables interpreters communication and is safe as sandboxes application at the same time. Uh, but it will be open source, so you can always check if Amethyst is done by no evil intention in mind. So as I said, it will be a separate AppKit application on macOS. The second thing uh, is that we need at the R side some kind of R package which we need to load and attach its functions to R's graphical APIs, and this package should know how to communicate through message port to some other application, which is Amethyst application. So, like Amethyst is two things: the R package and AppKit application, which will talk to each other. So, if we have some interpreted communication, we will have some kind of communication protocol. We can look at it as a list of graphical commands sent to another process, but I think I will focus on a binary version of such graphical commands to make the communication and interpreting such commands as fast as possible. Mm, so I look at it as some kind of binary serialization or binary communication protocol. Also, I would like to mm, to make the mm, the connection status between this R package and AppKit application seamless, that both sides of the connection know about its state, and that closing up will send not notifications so the R side can react to it, and also on the other side, when you close R session, Amethyst device will know what happened, but also will enable you to work without R on the already generated visualizations, for example, by exporting them to PDF. So this is the summarization of what I talked about technical design of Amethyst visually. So we uh, we have the right side of the graphical R's graphical API, but you can see that um, Amethyst device is divided into parts. One is the function and capabilities on in the R package, and the other is the Amethyst application. And they communicate through message port, but Amethyst Amethyst package will attach to R graphics APIs, which are described in R graphics device file header file, which I would like to just show you to make you uh, visualize what's really inside such API. So on the right side, you have some sample. But maybe let me go back to the beginning of the file. Okay, so mainly R graphics API is some struct which describes, first of all, capabilities of the device, which these parameters have to be filled with some values of capabilities of the device currently being attached or active. But also, what's what needs to be done is uh, pointing these function pointers, which represents the basic function which graphical packages invoke. Uh, these pointers have to be uh, pointing to the current mm, to the functions of current device, active device. And as you can see, these are really graphics oriented functions like circle, clip, uh, also general functions about the device itself, like the activate, for example, or another in, informations about graphics context. So this is the API, uh, and we need to attach Amethyst device to it on demand. So I plan that mm, final graphical capabilities of Amethyst have to support so at least some basic functionalities that ggplot and lattice or all base graphics of R can use and draw at least fundamental plots, just to prove that this communication works and to test different edge cases. And if the promises are met, I will implement all the capabilities to make Amethyst compatible with Quartz, but also mm, this will have some um, this will be a starting point for some other features, uh, but some some new features. Uh, but this is but first we start with a first stage of the project, which was what I described here. But when the promises are met, uh, some new possibilities can emerge, and we can continue with implementing um, some new features. So now we can think beyond the first stage and um, let our imagination work. So if we have such a device ready, in what are next steps? So what I'm thinking is implementing some interactivity in plots. Uh, there are generally plots which I showed you by default. These packages uh, are rather not rather how to say plain, not non-interactive plots. Of course, there are different packages which enable some interactivity or animations, but uh, uh, I would like uh, have it to research it and have it in two flavors. And the flavor I really like better is that the interactivity is independent on device side. So R would be free after defining and sending the commands to the device. R will be free to go on with its own, for example, analysis of data, some more um, heavy heavy operations, and the device would take care in different process and different threads about uh, interactivity. Also, the second flavor is the interactivity controlled by R code. I've seen that uh, API has some possibilities uh, to get events like keyboard and mouse events from the event loop via the R API, but it probably needs some active loop from R code as well. But I would like to research this possibility as well. Also, of course, in the R's world are many packages which also use web development techniques, emitting some web pages full of JavaScript, CSS, and HTML, of course, uh, which then uh, o- open web browser and present interactive animated uh, plots. But my one of design assumptions is that I really need, um, I really want to implement this natively, uh, so without any intermediate um, interpreted technologies like web technologies. Um, and also uh, uh, like make it everything compiled uh, and as efficient as possible. The other thing I can think of in such a device would be interesting and fun is to have non-blocking animations, something which which could be used together with interactivity. Uh, by non-blocking, I mean uh, that R is non-blocked controlling these animations. It only defines it. So, something like in web development, but when you define some CSS animations, but of course I would like to have it natively on macOS, um, and I think of implementing it in two ways. First, maybe some at first with some fixed functions. So the Amethyst app has some possibilities which we can only mm, uh, order through our package, and uh, and Amethyst app will run them independently, but they are fixed in the sense that what is defined in the Amethyst by Amethyst developer will be available only. But maybe in the future, mm, uh, some user-defined animations could be also sent from R to Amethyst, which would uh, in incorporate in its run loop and interpret it and run such animations. Uh, it resembles to me the history of graphical capabilities of graphical cards, which at first has fixed functions uh, for graphical pipeline, but now we have really like custom customly written shaders, which also led to other computations than graphical ones. But it's not my my goal for now. But who knows? Who knows? Uh, in the future, the project can really pivot in or fork in different directions. But I'm not focusing on it right now. What other possibilities emerge in the future when we have Amethyst ready? We can attach it to other languages which lack graphical capabilities or they have own capabilities, but maybe uh, we can mm, show that Amethyst is better or more convenient for some reason. Mm, so we can attach Python to Amethyst via the same protocol or other languages if any any fan of particular language would like to implement such protocol on in their language, favorable language. Or even if you fancy, you can make your own graphical language to have some fun with graphical demonstrations or graphical simulations or art, graphical art. Uh, so you can design something like processing language to ease yourself and have more higher level graphical routines. So because we have some interprocess communication via protocol, it enables us also to adapt it to network communication. So I can imagine even that our graphical device, Amethyst, is run on graphical station like Mac, and but the R process itself is on different platform, maybe on some server with high processing power, and they communicate with each other, and our session is sending graphical outcomes of data analysis to the graphical station. It resembles a little like X11 works. Okay, and that's all. Uh, that's all about my presentation. I will stream the progress of my project on Twitch and also upload some chosen clips to the YouTube. Um, so please, if you'd like to track the progress, to have some to give me a feedback, if you have any questions, you can attend to my Twitch channel or comment in a YouTube. YouTube channel is mentioned on my Twitch uh, description of the channel and vice versa. So you won't get lost if you would like to contact me. Okay. Thank you very much and see you next time.